In this lesson for BobCAD-CAM, we're going to look at creating a fourth axis vertical milling machine. As you can see in the simulation window here, this represents the machine that we're going to create in this lesson and set up the travels and add some geometry as we have here into the simulation. So you can see this has an indexer parallel to the x-axis, so the A is rotating around the x, and the indexer head is placed on the right side of the machine. It's got vertical Z, X, and Y, just your standard fourth axis machine. Now, when we go to pull travels off of your machine to set up for this, you want to know how to locate and where the travels are coming from. Now, for this instance, we're going to say the overall travels of the machine, it's 40 inches in the X, 20 in the Y, and 18 in the Z. Now, you want to know the difference between the virtual machine home or zero and your real machine home is zero. So your actual machine in your shop is going to have its home where you lift the head all the way up, bring the table all the way forward, and X probably all the way to the left position. For the virtual machine home, we're going to right-click on this, any one of these little axes here in the Axis Control tab, and set all to 0 and press OK. You can see it's the face of the spindle brought down to the center line of rotation, the center of the spindle in the Y, and the center of the spindle, the X face. The face is X0. Now obviously you're not going to bring the head down into the indexer there to find these positions. So what we'll do is we'll just lift the head up just above it. But what you'll want to do is you want to line up the X with the center of the spindle at the face, and then you want to get the travels. How far from that position can it travel positive in X and negative in X? So for ours, we're going to say from that position it could still go X positive 10 inches but minus 30 to get our overall 40. And then what you'll want to do is the same with the Y. You know, how far can it move positive and negative in the Y from that position, and we're going to say it's even at the center of the table, which in this case would be, let me reset this here, which would be plus and minus 10. Then what we'll do for the Z is obviously you'll move your X over to where everything's clear, and you want to be able to bring the head down now to where that center is at 0. From there you want to know how far negative you can go, and it's positive. So we're going to say we could still go 4 inches negative from that position and a positive 14 for a total of 18 inches. Then the last travel distance you need to know is the rotation. A lot of indexers have a limit on how far they can spin positive and negative. For our example, we're going to use positive 9,999.999 degrees and negative the same before it has to lift ahead and rewind the indexer back to the 0 position. So now that we know where the travels and everything are coming from and how to locate everything, let's go ahead and close this down. And we have a part on the screen so we can get into the simulation there. But let's go ahead and create our machine. So we're going to right-click Milling Tools. We're going to go to Default and Current Settings. Under Machine Parameters, we're going to add a machine. We're going to call this the 4_axis. We want to have no spaces in the program, so use underscores or just make it one long word. Underscore vertical underscore mill. This is what we're going to call our machine. Since this is a standard 4-axis machine setup, we can use the 4-axis machine template. If yours was like a horizontal or something like that where it's not the standard layout, you're going to want to go to user defined and actually create the layout of the axis. But this is a standard one. If I choose the 4th axis machine and press OK, you can see it says number of axes is 4. So now when I go down to machine definition, it gave me the basic template to use of a standard machine. Makes it real easy to do. So now we're just going to start by going in and setting our travels. We'll click on Y first. Now over here, the way this is laid out, we have our positive and negative. So we said on our Y, we're going to do minus 10, enter, and plus 10 for a total of 20 inches travel. The 1 is on the axis that's moving, so 1 is on, 0 is off. And the way it works is if the head itself is moving on the axis, it would be a positive 1. And if the head is stationary and the table or workpiece is moving, it'd be a minus 1. So in this case, our head is stationary and our table is moving back and forth in the Y, so it'd be minus 1. And then your initial value needs to be somewhere between your minimum and maximum values. It can be the same as either of them, just can't be outside of them. Down to X, the same thing here. We'll set our minimum here of minus 30. Enter, and our positive can go 10 inches. Enter. 0 is between them, and it is, again, the table is moving, so it's minus. A, We're going to put 1 in here because A is what's moving in this case. We're going to put no center point of rotation. It's right at the 0 where we're locating everything. If it was off from that position, we would want to put that value in here. And then again, we said minus 999.999 minimum and maximum rotation amounts. I've seen some HAs where it would be just, minus 999.999. So make sure you have the right value there that you need it to be. 0 is between them, and we're good. We'll come down to the Z. Same thing. We're going to say we can go minus 4 inches, lower than our 0 position at the center of rotation, and we can lift up 14 inches as well. 0 is between them, and the head is actually moving on that axis, so it'll be 1. You can also see it added the workpiece transform, which has the tool, the flute, the shaft, the arbor, and this is where you would come to change the colors of those if you want to, as well as the workpieces sitting on the A, because that's where the workpiece would be attached, and you could change these colors as well. We've also added in with the template some cutting conditions where it sets up the stock and the workpiece and the tool for collisions. You can add additional stuff to that as you add geometry to it. So at this point, we could just run it as it is. So let's just go ahead and OK that. Now we'll go to Milling Tools Part for the current part file we have open and click Current Settings. Go to Machine Parameters, and let's choose that machine that we've created right at the top. So now when I go to Modules and Mill Simulation, we should be able to simulate with that machine. We won't see anything because we haven't associated any geometry to it, but the tool should move properly on the part. Takes just a minute to open up. So you can see here's my part, still loading. So again, here's my part. Here's my travels, and you can see what these are out here are when it hits its maximum rotation, it has to lift up, rewind the spindle, or the rotation, not the spindle, but the rotary axis, and come back down and continue on. So you can see if I turn off the tool path, the initial workpiece, and the thing. Actually, let's turn back on the workpiece since we haven't made our stock transparent so you can see it in there and hit play. You'll see it's actually moving correctly as it's rotating around. So you can see how that's cutting out there. So even if you don't have the geometry, you should still be able to simulate your part correctly. You can see the different axes moving here. It's going up and down in the Z. The A is rotating, and every so often it steps in the X. The Y is not moving in this case. It's staying right on center line. So I'm going to go ahead and stop that. Now let's go back out of here. Let's go back in and add some geometry to the machine. The first thing I need to do is I'm going to go into my C drive. What you'll want to do is have STL files of all the different components saved out. And where you want to orientate them in the CAD window is the grid 0 would be that same rotary 0 that we were looking at for the simulation and located all of our numbers from. So I'm going to go to the C drive, BobCAD-CAM data, the correct version of software, and the machine simulation folder. Inside here is the machine folder that we are working with. You notice there's no STL files in here. This is where you would want to save those to be able to pick those to add those as geometry. I'm going to pull them right out of here. So I'm going to grab this one through here. I'm going to right click and copy them, back up, open this one up, right click and paste them in. So you can see now I have those to choose from. I can close this down. So we're going to go Milling Tools, Default, Current Settings. We're going to choose our machine and hit Machine Definition. Now what we want to do here is we want to right-click on the main name first and add a geometry. Now the base we're going to do to this one is we want to be in that folder, and we're going to use the actual base. So we're going to use the Rotary X base one here. Have these named so you can see them easily. So when I click on here, I can give this a name. Now the name I'm going to give this one is going to start with MH underscore in lowercase. I'm just going to call it base. No spaces again. The reason I did that is that will allow me to turn this piece of geometry on and off with a button in simulation, as you'll see. I'm going to click in here and change the color of it. And that's all set up. So we'll come down to the Y. We'll right click. We'll add a geometry to this one. The first one we're going to add to this is the Y base. So we're going to use the X, Y base right here. Open this one up. and then click on the geometry, and we'll call this one MH underscore Y axis underscore base. We'll choose its color and OK. You can see we've named this MH again underscore. Remember, no spaces in the name. Once we have the Y-axis base, we want to do the X-axis base because it sits on that one and moves along with it. So we're going to go back to Y, add some more geometry, and we're going to do the one that's called XX base in this case. And we'll click on that one. They could be in any order here. They're just both tied to that Y. We'll name this one MH underscore X axis underscore base, and we'll pick a color for this one. So now that we've got those two set, under the X assigned to this one with geometry, we're going to do the table. Just the main table because it sits on the X. We'll click on that. We'll leave this one showing all the time and we'll just call it table. Pick a color. Maybe we want this one a little bit lighter. Also on the X, we're going to have the rotaries base that sits on the table. So we're going to add geometry for that one. And we're going to look for rotary base right there. And we'll pick a color. Let's do a little bit different color for the rotary base. And then we'll name this one underscore base. And we'll leave that one there all the time. Correct my spelling. All right, so here we have X with the rotary base and table, and then with the A. Now the A is just going to have the rotary face assigned to it because that is the A, so we'll put the geometry for that one. And we're going to look for what the face is. We'll go on to that geometry, rename it rotary face. Click on the color of this one, and maybe we want the rotary face to be a little bit darker again. All right, so we've got this side. Now we got to come down to the Z, and we're just going to add the Z-axis to this one's geometry. And this will be the spindle. Click on that one. This one we will do MH underscore spindle again, so we can turn it on and off with the button. And we'll pick a color for this one. Let's do the darker color again. So those should all be set up, and we've added geometry to these. We added a base, the Y and X axis base. Those are all turn offable. The rotary base and table, we want those to always be visible. The rotary face will as well, and the spindle can turn on and off. So if we OK this, now we go into make sure we have the machine chosen. So we'll go to Milling Tools, Part, Current Settings, Machine Parameters. Yep, that's the one that's chosen. And we'll go to Modules and Mill Simulation and see what we have now. This will take just a minute to open. Okay, so here you can see the machine. Again, we've got the toolpath and everything like we saw before. So we'll turn off the toolpath, the initial stock, and we'll make that transparent. But you can see here we have the rotary and the face and the table. Those are the three pieces that we made always show. We didn't have the M underscore H with them. The rest of them are turned on and off by a button, and that's this one here, which is machine housing. That's what the MH stands for. If I turn that on, you can see there's the rest of my machine. And the nice thing about that is if you don't want to see it all the time, if you assign the M underscore H at the beginning of the geometry, I can make it transparent or turn it completely off. And now I'm just looking at, this area here, hit play, and I can watch it cut. So however you need it to do. And you can see all the axes is moving around here. So again, you want to make sure everything's located correctly. If you do assign geometry, make sure the STLs are located correctly in the CAD to the 0 of the virtual machine 0 as well, and just assign it all in there. You can change all the colors of your tool, the geometry, and everything also. Okay, so once we have the machine created, ran simulation, and everything looks good, we want to come back to the milling tools, go back to default, current settings, make sure your same machine's chosen. You'll see all the definition we just set up. And we're going to come down to the posting tab. Now you want to go down through the posting tab and set the correct post processor that will be called when this machine is called. So if I go into my C drive, data, current version, posts and mill, make sure you install the correct post to that. So for this case, maybe we'll use the Haas 4-axis OEM. Say it's a Haas machine control, different tool pattern selection if needed, NC file path will be fine. You can set what the file extension is needed for that machine. Default program numbers and such. Once you have all this set, those are the ones that are going to be the defaults every time you call that machine. They'll come up in the CAM tree. The next thing down is the multi-axis posting. You can see you have all your different options to be set up in here. And for 4-axis, you really shouldn't have to change any of these options inside of here. There is a video that will contain information on all these settings in more detail though. So once we have all that, we'll just press OK. And now you can see when we come in here again, if I was to go to Milling Tools, Part, Current Settings, Machine Parameters, I'll just click off of this at first. And then click back onto this. There. You can see it crawls the correct post and everything in the tree for me as well. This concludes this lesson.